Hello, this video is about the polyatomic ions and what is it? How does it work? So let's start with ionic bond. As you know, ionic bonds is formed between an anion and a cation. Cation is positive, anion is negative. So the electrostatic attraction between the two things form the ionic bond. Now, the very simple ionic bond, an example is NaCl. The Na have the positive charge, the Cl have a negative charge. They attract each other. Some of the ions, though, consist of more than just one atom. They are poly means many atoms covalently bond together. That's the key thing. So when the ionic bond that consists of the covalently bond together polyatomic ions dissociate in water, the atoms inside the polyatomic group goes together. Example, CO3 2 minus, SO4 2 minus, NO3 1 minus. So these guys, this 1C 3O are covalently bond together, and together they have a 2 minus charge. Same with this 1S and 4O bond together they have 2 minus charge, and NO3 they goes together, and together they have 1 minus charge, which is equivalent to 1 extra electron. Most of the polyatomic ions that you are required to memorize is anion or negative ions, but one of them, will be a cation, NH4. So 1N, 4H, covalently bond together, having a positive charge. Okay, well, how do these things look like? I can give an example over here. So 1N, 4H. So even though we write it like this, because it is a covalent bond, these guys can form a Lewis structure that have share electron, which is the line. So nitrogen have 5 valence electron. Hydrogen each of them have 1 valence electron, so 4. So together they have 9 electron. Now all together, these guys have a positive charge. That means that they lost a 1 electron. So 9 minus 1. So in all together they have 8 electrons, and that would be share among those atoms. So NH4 looks like that. Okay? And so an application of the polyatomic ions is that when you have a cation and an anion bound together, the charges have to balance out. Just like when you have Mg with Cl, Mg have a 2 plus charge, Cl have 1 minus charge. When Mg combined with Cl, you have to balance out the charge. So 1 Mg will go with 2 Cl. So in final, you have MgCl2. Right? Same deal with this. If you have 1 Mg combining with a polyatomic anion such as CO3, you have to balance out the charge. So Mg 2 plus, CO3 2 minus. When you combine them together, you will have MgCO3. Good? Now if you have something like Na, which only have 1 valence electron and can only form Na plus, combining with CO3 2 minus, then to balance out the charge, right? 1 plus 2 minus, you need 2 of this guy, so you would have Na3. Yeah? Now polyatomic ion is exceptionally useful when it comes to balancing of the equation. So an example, when you look into this is a nonmetal, oxygen's a nonmetal, Hydrogen is another nonmetal. That means that OH is covalently bound together as a polyatomic ion, right? And OH together would have one negative charge, while Na have a positive charge. When NaOH reacts with, let's say, H2SO4. Now, H is a nonmetal, S is a nonmetal, O is also a nonmetal. However, since we know that this is an acid and H will come off of them, we can kind of consider that H will be will have a positive charge and SO4 have negative charge. And SO4 is your polyatomic ions. Each of the H have one positive charge, SO4 will have two negative charge. When you have a reaction like this, you can predict the product looking at the positive and the negative. So Na, having a positive, is going to go with the SO4 having the negative charge. So Na, SO4. Now SO4 have two minus when Na have only one plus. So you're going to need two Na to balance out the charge. So this is one of the products that you get. Sorry, adjusting here. The other product you may predict is H will go with OH. And as you know, H, O, H, that's water, right? So, second product you have is water. Now also, the knowledge of polyatomic ions is also useful to balance an equation like this. So you will balance the polyatomic ions as a whole. So before the reaction, mind you, the sign means before and after, right? So before the reaction, you have SO4. After reaction, you still have SO4. This group have gone together. So you could balance them as a whole. You have one SO4 here, one SO4 here. So that's all set. If you do it the method of splitting them out, you could say, okay, before the reaction, you have one Na, one OH group. Again, OH goes together, right? 2H and one SO4. After the reaction, you have 2 Na. How many OH? Right now, 1 OH, right? HOH is water. So 1 OH, 1 H, and 1 SO4 group. Okay? So you can say, okay, Na is not the same. So I'm going to put the 2 out here to make this 2 Na. But then that have changed your OH group to be 2 OH group as well. SO4 is fine. Okay? So now that you have 2 OH group on this side you're going to need 2 OH group to balance out with the 2 OH group on this side. So I'm going to put a 2 here. So then let's make this, and that will also change your H. So you will also have 2H here. And voila, everything is balanced. It's a lot quicker than if you balancing each individual S and the individual O.